Okay, wonderful.
Great. So I will introduce today's speaker, Rudolph Pienear from Harvard Medical School. He's an assistant professor in radiology and actively engaged in architecting novel approaches to computation, particularly in image processing. He leads a team within the Fetal Neonatal Imaging and Developmental Science Center and has developed a lovely open source, open science platform called ChRIS that he'll be telling us about today. Rudolph and many of us who are in the Center for Morphometric Analysis lineage have worked together for a very long time, and it's great to invite Rudolph to present to this ReproNim venue. So without further ado, I will turn the floor over to Rudolph.
Great, thanks, Dave. I'm actually super happy to be here. As Dave said, it seems a lot of old CMA folks around, so it's nice to see some new names who are in the CMA before me, after me, maybe. And I see Christian is around. Shout out to him. We had some good times programming a lot of cool stuff back in the day. And in some ways, what I'm talking to you today about is almost an extension of the ideas and experiences I had back in those days. So first of all, can you all hear me well?
My answer is it's pretty good, but a little choppy.
Okay.
Yeah, that's true for me as well. It's a little bit warbly.
All right, I will try and enunciate carefully. So the thing is, I'm on a Arch Linux machine, and Zoom, as always, wants to mess up my microphone settings. So we'll sort of muddle through, but I stop me and say if you don't hear something or you'd like to. So I'm going to talk about the platform we've put together over at ChRIS, and how it is geared to be maybe well positioned to work with other platforms, and how it is geared to help computing, especially in this age of AI. I always like putting AI in quotes, so I'm going to do that, AI, and clouds, whatever all of these things might be. So there's a copy of this out on that website. Well, there will be a copy of this also out on that website. This is not a PowerPoint. This is like a web-based thing that was coded up in Vim. So I can share the basic text source file, but it's more useful if you run it behind a web browser. Okay, so who am I, right? So I did a postdoc back in the day at MGH. I worked with the Free Surfer group. I worked in the CMA. I began working with someone called Ellen Brad, and when she moved to children's, I moved with her. There's a picture of me, which I always put there to remind myself of times when I went outside when it was cold enough that it didn't matter whether you used Celsius or Fahrenheit, it was just pretty cold. So again, speaking about time, how time flies, right? I did a PhD in biomedical engineering using a machine learning technique called reinforcement learning. And that informed a lot of also how I approach what is AI today. So I'm just going to put a pin in that. So when I complain about stuff that might be coming from this experience, a lot of control systems, muscle modeling, nerve impulse strain, simulations, stuff like that. And then I did a stint at the Free Surfer dev team and also the CMA. And from there, as I hinted, I moved with Ellen to children's. And the FNNDSC, the Fetal Neonatal Neuroimaging Development Science Center, we are actually thinking of changing the name. So that might be. Where I lead a small group, we call ourselves the Advanced Computing Group, where we focus on stuff like I'm going to talk about today. So a lot of software. Software has mostly been what I've been involved in professionally for most of my time. So this talk aspires, right, to tell the story of ChRIS. I'm going to try and tell a bit of a story more than just giving these technical slides. And hopefully, in the telling of that story, it'll become clear how ChRIS relates to medical computing and to clouds, which I'll show in a bit of a demo, and also how AI or AI workflows can be leveraged in the system that we put together. So I'm also going to hopefully touch upon, or it might become self-evident, how something like ChRIS is complementary to NetReproNim. And spoilers, I'm going to say why I think this is the case, like from the get-go. And this is a philosophical viewpoint, but my assertion is that given the history and experience that we had, ChRIS is what I would call a compute-first platform, where data is, I'm putting second in quotes again. That's not to say it's not important, but it is to say from an architectural perspective, we focused on how do we represent compute? And data is just the stuff that flies between them. While a lot of other systems, and correctly so, are coming from a data perspective. What is the data that users want? How can we use the data as a connective tissue to string things together? And the compute that does all these transformations, well, that's a little bit in the book. So from that perspective, one of the weaknesses of ChRIS, I would argue, is that it doesn't have a nice data experience, but it has a good computing experience. So, I could jump ahead and give all these technical sounding terms and slide like, oh, it's a pervasively open source platform. All the compute we run are containerized, and we try and help folks build these containers. And those containers can actually run outside of ChRIS quite happily. You don't need ChRIS to run ChRIS containers. We have these linked lists of tree-like container structures that ChRIS will schedule and run through. And it's all about, the reproducible compute, sharing and collaborating on compute, as well as I could also jump ahead and say that, we try to be cognizant of non-technical issues. And that might become obvious in a little bit when I get to a bit of its history. At the same time, we try to provide a low barrier to development. Part of our philosophy has been, how do we enable developers, and I'm going to talk about what developers mean. How do we enable developers to be productive, to get their stuff in a platform like this with as little friction as possible? Now, the devil's in the details. Friction can mean many things, but I'll talk about what it means to us. And, ChRIS is a system that historically, given some of its needs, focused on a kind of web-based interface. But at the same time, I'm a hardcore CLI guy. And it's been fundamentally important for me to have a platform that is as expressively powerful from the CLI. In fact, arguably more so than from the. So we almost have a CLI-based core DNA system to which the UI is always trying to catch up and expose features up versus the other way around. And I think that's given us a lot of agility and also innovative kind of thing. So, I could also do these slides like ChRIS supports Docker Swarm and Kubernetes native, OpenShift, which is above Kubernetes. We even have connections out to Slurm and HPC. And the sort of the take home with this is that a developer writes their app once in a ChRIS container, and then they can get to run that on any of those backend platforms without having to know or care how it happens. So, they have this thing in giving talks these days, you should always tell a story. That's how you can engage in your users and listeners. And okay, well, this is exactly the wrong story, but kind of similarly to this. Once upon a time, I was starting to be a postdoc back at MGH in the early 2000s. And my first project was to work with case-based data, right? And that scroll actually continues. I took time to type it all up, so it's there for the possibility. But it was all about changing, doing mappings from case space or image back into image space, and that is not me as a postdoc, but that's the idea, right? So that's the wrong story. But what I was doing was trying to make an app that would take your Siemens MRI case space data and And this happened because back in the day at MGH, in 2000, which is still the case today, right? Folks like Andre van der Koe would be developing these interesting sequences on the scanners. And he was making sequences that would capture too much data for the hardware of the day, the MRI machines, to reconstruct in real time. Or even at all, they just didn't have the memory. So Andre would have sequences that would just dump a whole bunch of case-space data on the MRI arm. We would pull that data off, and now how do we reconstruct this? How do we quickly, get the images from that? So that was my first project, and it was a very fun project. It's back in the days when I was doing C++ programming, which I've mostly forgotten. I was writing libraries and just having a grand old time, right? I was doing stuff like with C-Blast and the GNU Scientific Library. And I thought this was a pretty cool app. But I was to learn many things in those early days, and this is just one example. So software, especially in research, especially as developed by people like, people like us, is usually written by non-software devs. I had no formal training in as to write software. I mean, I come from engineering, not even science. But a lot of software in research has arguable quality. And the fact that it is arguable in its quality also impacts what is a very important side effect, which is easily disregarded. And it doesn't actually live very long. And well, it's appreciated that is true. But the key point for me first, before reproducibility, was I began to be aware of how short-lived research software is. Did anyone else, subsequent to me writing a case-space, inverse FFT little app, have a use for something like that? I'm going to guess probably. I couldn't have been the only person that was writing these, inverse FFT case-space to image apps. How many times was that wheel reinvented? Probably lots of times. This was again before GitHub, stuff like that. And not that GitHub today is a fancy. I could argue that GitHub is so full of stuff that it's really hard to find this stuff. But I began to realize that if things could live a little bit longer, they might have longer utility. So at the same time as this was going on, I was writing these apps, working with these things, whatever we were doing, I was also working very closely with Ellen Brown, who was a clinician. And it's been my really good fortune to be paired with someone like her for most of my professional career, because she's rare amongst clinicians in that she appreciates not only software, but the process of the software. Possibly because she's very open-minded, which she really is, possibly because she comes from undergrad physics background and master's in physics. But she gave me the freedom to help create things for her use. And she would have very straightforward needs. It would typically be, hey, Rudolph, oh, we ran a scan yesterday. We have diffusion data. I don't know how to run this through the diffusion toolkit. Can you just pull it from the packs and just run it through the diffusion toolkit so I can look at the results? And this happened a lot. And, as most of us who are lazy devs do, I was like, this should be scripted. I mean, I'm not going to sit there and click my way through something or do the same things over and over again. And so began the well-trodden path of writing a lot of scripts to try and see. Now, I realized that clinicians, and I'm going to, just for the sake of effect, right, just be completely generalizing. Clinicians will never open a terminal on us. I have yet to see one who does. So, I am very biased, but this is an important data point. But those of us who don't work closely with clinicians who have RAs, oh, well, the RAs don't have a choice. They have to run this. You give it to them and they do it. And I think the fact that from the beginning, I had to work with people who would not run scripts shaped me in other ways, right? no matter how much effort you put into writing this amazing bash script that you hope someone will use, they just don't ever use it. And then it became this idea that these two different user classes definitely shape the design of the system. So ChRIS did not exist yet, but in my kind of thinking, I was toying with the ideas of how can we bring compute to users who don't ever want to run scripts, who don't ever want to log into the Linux machine. We don't even know what Linux is, right? We tell them SSH and the eyes glaze over. But also maintaining strong bias. How can we service those users, but also service the users that I or myself am one, which is maintaining the strong bias to CLI or the kind of hardcore power usage. That's a pretty hard thing to do. And I didn't realize at the time how hard it would be. So, you know, if the user won't come to the compute, then obviously you have to bring the compute to the user. And in the early 2000s, mid 2000s, late 2000s, and you know, still today, right? That means doing something. And I thought in the beginning, all we need to do to get people to run these computing scripts is to slap a web front end onto it. Right? At least someone can go into a website, click their way maybe through, kludgily just get the scripts so that they can do something else. That kind of messy froth was what would eventually, over time, crystallize into what we call ChRIS today. It started off as nothing more complex than a web front end to running these scripts. And because these scripts had to be churned out quickly, and because the emphasis was on just running one analysis that would give on some data, and it had to be a whole bunch of different kinds of data sets, the focus began to shift inexorably to the computing. How do we abstract the idea of computing within this kind of thing? And you know, part of that is moving the complexity of this system, which you know, I will talk about later, into the platform itself. Have the platform handle as much of the complexity as is feasible, as is possible, and reduce the friction to the end user. You know, the less a busy human has to do, of course, the better. And then computers excel at so the needs, again, to just circle back, was to simplify access to very specific data. In our case, it was imaging data from a PACS, right? To make no requirements on what this data would look like as far as the compute component is concerned, and just make it really possible to see the inputs or access the inputs you bring in, and whatever is pushed out by the computing process. And this led to the next kind of design implication that became fundamental to the ChRIS philosophy. And that is every concept of computing in the ChRIS application, which we call ChRIS plugins, rely on the idea that there is one argument that is always going to be the input directory. And there's one argument that is always going to be the output directory. And this is sort of baked in front and center into writing these types. So you as a developer always have access to those two directories that is for your application. And you have to just explicitly always be aware that every single piece of input you are reading is relative to an input directory. And everything you want to be preserved by your compute must go in the output directory. That is part of the command line space. Right. So we can look at that in action a little bit more. But the focus has been on the analysis and to have the data fit analysis. So I like to always throw this slide in because it really made a big impact on me. Susan Gray, who's a really expert in UIX, just had this very obvious thing, but at least I can focus, right? If the user can't use it, it doesn't work. And for our computing, if a user cannot use our computing, if they cannot use our applications, they don't work, right? Or, the coloring, let's rephrase that a little bit. No matter how amazing a tool, right? By no means will I say my K-space inverter was an amazing tool, but no matter how amazing a tool, if it is never used, it essentially doesn't exist or never existed. And I wanted to rethink that. I wanted to make tools be long-lived, to be available beyond their normal lifetime, beyond the one particular project you're working on, the one paper for which you get results, to have that persist beyond that time. And that was one of the guiding philosophies or inspirations of the together. Okay, so I'm going to do a big jump now to AI. So I'm going to leave the kind of story of ChRIS a little bit behind. We will go to how clouds work in ChRIS in a moment. But let's go to a little bit about I'm pausing because I don't want to start ranting, so I'm going to take a breath. No, I'm not going to rant about AI. But AI consists in most people's minds, and the way it is often used today, of these words that are very anthropomorphic, right? We train an algorithm. We infer once it's trained, it is used to infer. And I'm going to use those words in this talk, but I often think that words matter, obviously, and the training is really nothing more than optimizing and tuning the functional possibility, and the inferring is just running that application. But ChRIS treats all applications. There's nothing magical about AI app or non-AI app. I'll come to what that means in ChRIS pattern. So again, I'm just going to get one quick slide on this. To most people currently, AI means neural networks, which frustrates me no end. And I always feel like just say neural networks. And just to finish this slide, I actually used Garden to prompt, and I said, draw me a picture of an algorithm that is sad because it realizes that all AI is just neural networks. And that seemed to be one of the things it came up with. So it has a ways to go. But nonetheless, as a technology, as a classifier, there is so much that it turns out, so many problems can be solved by good pattern classifiers, which at their heart is all that a neural network is. It is an exceptional pattern, discriminator, pattern classifier, however you call it. And it's, to me, the amazing thing about neural networks are just how many problems, real problems, can be solved by pattern classifiers. Computationally, actual neural network apps are pretty unexciting. They are no different to any other app that we might have built. They will take an input, right, an image, or whatever the input might be. They will do some kind of compute on that image and generate an output. Whether you're training, when you're training or tuning your approximator, you are still consuming a lot of input to tune that state space, that functional approximator, to produce all the weights as its output. This is a preserved model in all kind of what I'm going to call scientific community, where inputs are consumed, no matter what they are, in whatever capacity, to produce something useful. So, AI is big business. It's more than money business. And even right now, the way I look at things, we are seeing the stratification of what I'm going to call ML ops, machine learning ops. So, and there's a basic assumption that I question, and that assumption is that data scientists, I'm going to say data scientists, but you could just copy paste and say research departments, computational departments, writes their code in Python and Jupyter notebooks. And that is as far as they go. And now in the ML ops world, we need a whole new class of specialized skills to deploy and scale what we producers do. So think about that for a second. my reading of the tea leaves is that MLOps are stratifying two distinct classes of creators. And they were almost enforcing that separation, because what happens is that because the idea is that someone writing an app does not know about clouds, does not know about how to scale an app, does not even know how to containerize. Well, we won't bother them with that. We won't make it easy for them to do that. In fact, what we will do is tell them to stay in their Jupyter notebook or their small command line Python app, or in the case of work your way through that. And when you are done, someone else will come and take your Jupyter notebook and either crystallize out an application or take your original application. And I'm just assuming for the sake of discussion or Python, it doesn't have to be, but it's that way. And what that person will do is they will use a framework like Fast API to provide a REST API web interface that sits like a shim in front of and around the actual core application. And that is usually containerized. And they can take that application and then at scale throw it onto some kind of package. That's great. It works, right? People are doing this. I was in a talk with Red Hat earlier in the year, was at their summit, as a matter of fact. And there were so many talks about MLOps and so much money being pumped into how to make MLOps easy. And it is all this. It's separate the producer, the actual data scientist or the research developer, from the complexity of deploying their stuff. And we're going to put a lot of money, a lot of tools into making that possible. There's a big problem with that. So it entrenches the fact that a lot of these applications, if I write an inference model, if I train a model and put it into a wrapper and run it, it's just a single shot thing. I have a fast API wrapper around a one-shot thing. It's not really easily part of a bigger system. It is self-contained. That's self-contained in its container, but it's also self-contained conceptually in its core. How would you get a BIDS data structure, for argument's sake, into fast API file? I mean, I'm sure there are ways to do this, right? But with moving further and further away, we're entrenching this separation between these two groups. And what happens in that case is when things go wrong, which they almost always do, there's a large amount of finger pointing, right? The data scientist will say, well, it's not working, it's not my problem, it works in my little Jupyter notebook. And the DevOps engineer will say, well, I'm running the thing that you gave me, it's just not working. And there's a long back and forth of finger pointing, debugging is difficult, everything slows down. So what are MLOps in ChRIS? Well, in ChRIS, because of its model, because of its idea of making it easy for developers to create their code, there's no different deployment model between your final product app. Okay, asterisk, asterisk, asterisk. You do have to build your Python app with one of our templates. I'm going to show you what that looks like. I don't think it's onerous. And it tries to get out of the way. But the point being is that the thing that you create is the thing that is. No one else is coming after the fact and slapping another API in front of that. When things go wrong, or when you need to tweak things or change things, you are right there to be able to do it. You were able to reproduce, you were able to debug, all of this kind of stuff. All right, so I'm keeping an eye on the time, so let's jump ahead and try the thing that I never say to do, which is to write a demo. So the first thing I'm going to go to over here is let's talk about what it means to what does compute mean? So let's go to ChRIS store. There's a bit of a story here, which I will get to. It's going to actually redirect us someplace else. But let's start. There used to be once upon a time a ChRIS store, like the App Store, the Google Play Store. You're thinking, hey, right, let's have our own store where people can upload their apps. So if you go to chrisstore.co right now today, it takes you into our public ChRIS that lives out on the web. And here we see a list. There's three of them. Oh, actually, I was looking out because it's not supposed to. The whole point was that there we go. So you don't need to have a login to the ChRIS system to go to the store and see this. You can just anonymously browse it. And here is a list of all the applications we put up out there. I'm not going to go through any of these in too much detail, but let's just take one random example. Here's something that says an app to convert a CSV generated from one plugin to a JSON. So what's that? Let's click on it. And we can see that what we provide here is essentially the read for this app in this case, that's on and we provide, you can have multiple versions of the same app in the system without it. So you can, if you want to specifically run version 1.0, you can do that. These do not interfere. And I think the resources doesn't work unless you log in. So let us log in to just and again, this is the public facing ChRIS where everything is, all the data that might be out here is anonymous. Anyone can go in and play around. We just make no guarantees that stuff you put out there will persist. But let's look at the plugins, which is where we were without having logged in. So you can see if you've logged in, you get this extra stuff on the side. There's some other stuff going on. And I think we looked at this one over here. So same thing again. We were here before. If I look at the resources, you can see the command line. Sort of as if you were to see what all the command line are. And depending on how well the developer wrote their README, they might, this is not enforced, of course. If they wrote a good README, well, then all that stuff is explained directly in the platform, in the app, for the users. This is certainly developer bias, right? Again, part of the idea was to have conditions be able to use something like ChRIS. Some might, but what I'm showing you guys here is sounding more like 100% development. Now, let's say you fired up your own ChRIS, for fun and kicks over the weekend, which I'll show you how to do next. And you wanted to get this particular app into your ChRIS. Well, you could just copy paste this link from our public main ChRIS and use the admin backend to get that application into your own ChRIS. Which, speaking of which, how do you fire up your own ChRIS? Each one that will be fine. So you can go to GitHub and there, that's just my first hit. And we have a very friendly shout out to Jenny's Zag in our group who we put this together. Mini ChRIS doc, which you just check out this repo. And when it's bigger, you just check out the repo, cd into the directory, and run the shell script. And voila, you will have a fully functioning ChRIS on your local machine. Two important caveats. You need to have obviously the infrastructure Docker installed on your machine. So that's the exercise for the reader. And this does not work on Windows. I make no apologies per se. It might work in WSL, but this is a, Linux first citizen, Mac OS somewhat close first, but 1.5 second citizen, whatever. We just don't have the resources to try and make this work. But if you were to have Docker on your machine, then you just do this and you are good to go. For those of you who might be more Red Hat Linux inspired, or at least like the idea of Podman. We also have, instead of using Docker, which has its issues, we also fully support the completely open source Podman over here. So mini-ChRIS Podman will be the same thing, except using Podman as well. Right. So in theory, you could just do that. I won't show how we fire one up now because I did two different questions. I wanted to show them two things, but you could, after this talk, just do that. Pull down mini-ChRIS, fire it up with the machine. Let's see, what could you potentially find out? Well, I am going to switch to internal one. So I'm going to now show you what some of these things are. Again, this is our internal VCH group, so I can't show you too much of that, but I wanted to show you analysis of this. So I'm just going to show you, well, let me go back in 1 second. Here we have a list of all analyses that a particular user did. We touched upon the compute. Oh, sorry, we touched upon what plugins are the actual apps. We support the idea, and this is what I want to segue into, of different compute backends. So we have these, what we call compute environments, that are a property that can be applied to every single compute in this ChRIS order. Right? So we have a Power9, IBM Power9 machine that has been donated to us, which you can transparently run your apps on. And now I can hear someone saying, "But wait a minute, that's ARM architecture. How is this all working?" If you use our template, our plugin template, and build your ChRIS app, we use GitHub Actions to automatically compile that container for x86, 64, for straight up ARM, Linux ARM, and also PPC, 64, whatever it is, Power9 architecture. Here, these compute environments over here are Slurm, HPC Slurm clusters, right? And we just created a new environment for every Slurm here. But most of our stuff we run on something called Pienear, which is our in-lab Kubernetes cluster. So each one of these plugins can be used to build an analysis, and each one of them can be told to run something else. So let's look at one of these. Here is an analysis that is typically coming from the clinical side. This is an automated pipeline that when something happens way upstream in clinical lab, there is a process that, let me take this back. So, and this is anonymized, so I can show you this. At the very top of this tree, for whatever reason, we made it grow downwards. You start at the root. At the bottom, each circle you click in, which is one of these containerized apps, you can see its internal file system. And here is what is being fed into this particular. There's what we see. And by the way, this is Cornerstone that we're using here as a library to do this. And the whole purpose of this work here is to run an inference that tries to pick out where the joints are located, and then just straight up measure what is the length of each of these things. I'm not going to go through each one of these in detail. What I'm just going to say again is every single one of these containers can be told to be run on any one of those compute platforms I mentioned a couple of seconds ago. So you have the ability to have in one workflow completely hybrid kind of cloud as an experience. We also have ChRIS is deployed on the new human research cloud, and we don't have I'm not going to have a computer here for that at the moment, right now, because it's a work in progress. But you could, in theory, run some of your compute on-prem. Of course, you don't do some of that on-prem. And then some of it, if you felt like it, or if it made sense, you could dispatch out to NERC And all you needed to do would be to, when you add this node in your compute, just say, run this guy out on memory. And again, I want to circle back to say our design approach here has been to put the complexity in that the end user who's writing these apps, all that they care about, all that they need to worry about is their application, and not at all about how to get it on the cloud, how to even get it in HPC. If they don't want to muck around doing that, if they don't have to. All right, so again, what does this whole thing do? This whole structure that you see is specified, and I am time was mentioning this, is specified here. ChRIS docs repo is kind of a collection of a whole bunch of stuff. Arguably, they don't should all be in there. But if we look at what I was trying to show you, which is L and full, we describe this YAML file is the logical successor of those bash scripts that I certainly spent so many years writing back in my postdoc days, that some people here probably still spend time writing or have had that experience. Here we now have migrated to a single file that only defines the actual computing, the actual things that have to run, their parameters, and where they are in this tree structure. So this is something that you can create a priori. And when you tell ChRIS to apply this pipeline to your analysis, it will automatically build this tree, and it will handle the scheduling for you. It will wait until each node is finished and only run. So this circle over here, this container will only be scheduled when all of its ancestors are complete. Now, again, let's finish out this particular story so we can see what this thing was supposed to do. Well, I'm going to go over here. So we had a DICOM that came in. The DICOM was transformed into an MHA for Simple Toolkit. That's what the inference wanted. Inference would spit out JPEGs. The JPEGs were converted back into DICOM. All of that's going on over here. And if we look at the actual final output to DICOM, we see there we go. Here is the result of that workflow, where these red circles are where the inference engine picked up the joints, and it then connected them together using matplotlib or other of those containerized plugins to literally do nothing more than just measure these legs and generate a report. What you see on the screen here is a typical example of where we use this research-based computing to feed back into a clinical workflow. This DICOM can be pushed back to a clinical paths. Right now, in children's, it's pushed to a research paths, but the point is, clinicians, radiologists, actually make these measurements by hand as part of their workflow. So if someone is looking at these legs and their whole point is, I need to figure out if one leg is longer than the other, they literally, in the Synapse front end, they would, and imagine these lines right here, right? They would literally try and do this kind of behavior. They would aim and guesstimate, okay, put something there, that much right. They would make a note, usually on their phone or whatever the case would be, of that length, and they would, okay, we're moving next. This other length, or whatever the case may be, they would rinse, repeat. It would take them 5 to 7 minutes to just do this, while the drudgery of the computer can do this for them in a fraction of that time. Or it can have it ready for them by the time they come. Okay, so the other final thing about this thing that I'm going to get to is just to show you the entire I'll I'll touch on this one. So we have baked into this a whole subsystem that is able to speak to any text. And here I'm going to, actually this is fine. I'm going to speak to this. This one just has anonymous data. And I'm going to put in an anonymous MRN that is anonymized. Right, and this is the experience of the UI of these products. Everything you see here is all runnable from command line, and could be built into dedicated single apps as well. But here you can see, you can work with Axe Query. I think this one did not work. I mean, I tried to push it into view, but this is the experience of where you can choose. You can use this tool to go into the past, choose these studies of interest that you might need, either for research purposes or for clinical purposes, and pull them into ChRIS for consumption. We have spent some time into this idea of trying to build a copy, copy what we build, or at least be inspired by Dropbox or stuff like Google Drive to allow users to very easily be able to upload files from their local computer or wherever into the ChRIS system. Files have to be in the ChRIS storage for ChRIS to use it. This is one way in which we can get these files, and each of these are directories that can be nested in any depth that we want. Here is this particular one anonymized, and I think this one range. So you can get arbitrary data into the system through these through internet. Just looking what I wanted to show else. We do also have the successor that we're working on right now. A new take on the UI. This, what you're seeing on the screen, was written in Patternfly with React. We are now using or playing around with using Stealth as our new front end, which offers us a lot more power to do things in more compatible. Which I can touch upon in the question session. I'm just giving on the time just to be spent on going over. So what I'm going to do, I'm going to return over here. I think that's in mostly there. I was going to show what the new UI looks like, but let me do that if anybody's interested. Yeah, so I wanted to finish by giving thanks to the core team. I'm just going to give shout out to these folks. Jorge Bernal is our main backend developer. He has built most of the core of Q, which is basically this. He loves collection plus JSON. If you get him started on collection plus JSON, he will not start. I'm not kidding. Our front end is under the auspices of Pienear. Sandeep Samal has put together a lot of apps and workflows. Jennings is a jack of all trades and pretty much master of all of them. He is a great Rust guy. So we have our CLI tool for ChRIS is a Rust app, which apparently recently got in the top 100 scientific Rust apps, in the top 50. Kudos. A new addition to our team is Chow, who has a lot of stuff with getting the idea of maybe getting interactive Jupyter notebooks inside those ChRIS containers. And Ellen, of course, who is the person who made all this possible. And there's a rotating cast of RAs and interns and students throughout the time that I'm doing contents. I think that is it. So I will stop there for the questions.
That's great. Thank you, Rudolph. In the areas that we tend to work with, which are perhaps slightly a little bit more researchy and maybe a little bit less clinically, we run into a handful of very common tools: FreeSurfer, AFNI, FSL, and blah, blah, blah. Can you say a little bit about and maybe fMRI prep and bids and some of those types of things. Maybe I glossed over a little bit, but someone who wanted to do a bids app, somehow get your data into bids, somehow run fMRI prep, somehow run a, free surfer or a, FSL analysis. Can you say a little bit about how that interacts with a ChRIS workflow?
Yes, exactly. In fact, it might be best. Let me, my screen is still being shared right now. So let me. Here is a, here's a quick and dirty hack we plug in around FreeSurf. And all that this does really is that thin impedance matching fix between the FreeSurfer wall and the ChRIS. So this container will have the entire FreeSurfer, in which now this container is 3.8, whatever the size of this is. But any FreeSurfer command that you type that you want to run would just simply be massaged into the ChRIS CLI spec, which is make sure there's an explicit input directory and an explicit output directory. So the actual, if I were to go here and give an example, here's the Python wrapper around FShack. And we currently elevated a couple of these to be easily runnable from the outside. So, but they would all, you see over here is the command line requirements of this. So what it will do is the input and output directory are positional arguments. And then within that positional argument, you could give whatever input file you want. You would give whatever output file you want it to be. In this plugin, you would execute one of these that we elevated to first-class citizens. And then you would have a string which will contain all the command line apps that you would give to the command, or that you would give to the MRI command, and so on and so forth. So this is one very thin impedance matching solution to having an existing large thing like the server, and how you would bring that into ChRIS. If you look at the Docker file, it will actually go and pull FreeSurfer 7.3. It will need to have a license file, but it will build it literally. If you run this Docker file from scratch, it will take a while. It will pull the whole FreeSurfer for you, and then build this quick shim around the rating. So you could, in theory, take any app, like any FSL app, and make a shim of very complex. And sometimes it's we just half a page of Python to just map the input and the command line arguments that you would type anyway for that app, and just make them conform to the ChRIS requirement. So I'm not sure if that answers your question.
Yeah, my computer dropped out for a second, but no, that makes sense. Are there other questions out there in listening land? If there are not, so it, and again, I'm tangentially picking up some of these inferences that it's a thing. Can you say a little bit about either official processing, which is containerized, or other options that are containerized? How extensible is the system to additional processes already that are not necessarily part of it, but are new containerized processes?
Yes, I think if you have an existing container, which I'm not sure, I mean, I guess a FreeSurfer container, I think is that one, right? I mean, you can't take an existing container with its own idiosyncrasies and recontainerize that into the ChRIS one. You would have to, in that case, most likely read the Docker file into that container. And just to include a custom shim that will connect it to the ChRIS.
Okay, and that shim, one would imagine if the data is more BIDS-like, that shim might be easy or more similar to things that other people have already solved, or if it's custom, you have to solve that on your own and deal with that.
Yes.
Yeah.
I mean,
Okay.
we do, it would make a lot of sense to, I mean, what is it, QDCOM? I think we did do a plugin around QDCOM by one point, which would be, using the tools that are out there to, suck up input MRI or DICOM data and spit out a BIDS structure. And if you have another BIDS conforming app that, wants this BIDS as its input, well then, yeah, this is a way that you would do that. You would have the input filter that would make the BIDS, and then you would have containerized your BIDS conforming app. And yeah, that's how I'm doing.
Great. That's a great introduction to what this platform supports, and we can certainly have additional conversations. Others out in radio listening land, any questions? I know we've come to the end of our hour. I'm not going to throw anyone under the bus, but unless there are questions out there, I'll thank Rudolph for this, and thank you. It'll be on the web next month. Oh my goodness, Julie, do you know who's visiting us next month?
Sorry, Anisha Kashavan, I believe.
Ah, Anisha, and oh, who knows what she's talking about, but all sorts of cool things. That may be one of our connections to Flywheel. I know Andy is here from the Flywheel team. Anyway, so thank you, Chris. Thank you, Rudolph. I keep now getting into trouble. Oh, are you Chris or are you Rudolph? And I won't ask you in public who Chris is, but anyway.
We'll say, I can answer that very quick.
Okay, good.
It used to be, back in the early days, it was the Children's Research Integration System.